Let's look at number 5 from the section 9.7 worksheet. And we'll solve this exponential equation where we want to round our answer to 4 decimal places as needed. So when we're solving an exponential equation, we don't want to apply a logarithm until we have the exponential isolated. So notice in this case, the thing that's keeping the exponential from being isolated is the 150 times the exponential e to the x minus 4, which is equal to 300. So I'm just going to recopy this. Okay, so the easiest thing to do is to first isolate that exponential. And I'm going to do that by multiplying both sides of the equation by 150. Notice what that gives me. On the left, I now simply have e to the x minus 4. On the right, I have 2. So I'm going to apply the natural logarithm to e to the x minus 4. That's now my left side of my equation. And to 2, which is the right side of my equation. Now, the natural logarithm has a base of e. So this logarithm that we're writing here is the logarithm that gives me the exponent. Remember, a logarithm is an exponent that I need to apply to e, since the base of this logarithm is an unwritten e, so that I get e to the x minus 4. So obviously, this is x minus 4. So whenever the base of the whenever you have an exponential as input to a logarithm, and the base of that exponential is the same as the base of the logarithm, then you simply get whatever the exponent of the exponential is. And that's what we have here. So to solve for x, I simply need to add 4 to both sides of this equation. So I'm going to add 4 on the left, and I'm going to add 4 on the right. So I now have that x is the natural log of 2. Whatever that number is, I then add 4 to it. And I'm asked to round this to 3 decimal places. So I put natural log of 2 into my calculator. Many of the calculators work where you are going to hit the log button and then enter the 2. If your calculator starts a parenthesis when you hit the log button, you have to make sure you close that parenthesis out and then do your plus 4 after closing that parenthesis out. And to 4 decimal places, this is 4.6931. And so I could actually test this and check it to see if it's true. And I go back, whenever I check, I go back to the original equation. And let's just look at the check. It's not required to show the check. So I have 150 times e to the 4.6931 minus 4, and that needs to equal to 300. We know we're only going to get approximate values because we have put in an approximation. So I use my calculator. You can, if you want to, it may be a little easier to go in and do the 4.6931 minus 4, which is 0.6931. So this should be something very close to 300. And I actually get 2.99.9858. And notice that is approximately 300. So that does check out. Alright, so that means that x equal to approximately 4.6931 is indeed my solution. And if you're working on my MATLAB problem, it may ask you for the solution set.